All right, welcome back, everybody. We are in week 2. So thank you all for showing up on time. This week, we're going to be talking about algorithms and we're going to talk a little more about data structures. We talked about data types last time. So it's going to be data in yet another sense and a little bit more complex sense. Today, specifically, we're going to end up with basic algorithmic problem solving is our general goal is what we're going to get to today. We have to go through a few more things of syntax with Python first before we can really start doing and writing our own algorithms. We ended last time with a simple function. We're going to dive a little more into those, talk about some more control structures and things like that. But before we go into the subject matter for today, and we end up at the algorithmic problem solving, let's do a quick review of what we did last week, first 2 sessions. I know we covered a lot, but kind of the big things we want to take away and we want to remember from last time is that we talked about computers storing and understanding information as data in terms of bits, ones and zeros, stored in 8 of those as a byte, right? So that's one sense of data that we talked about. And that applications are just directions or algorithms written down in files in directories. And that whole concept of files and directories is like the most important thing that we're going to be going through again and again and again and seeing that over and over again. And if you followed along last time, this is actually the last slide, so I'm going to get out of here since, we're going to be mostly hands-on today. If you remember last time, I'm going to go just straight into my bash console. Where we ended was with a file, right? So here in my bash console, if I do ls to show where we are in the home directory and list the items that are there, we did this main.py file, right? And in that file, we defined a very simple algorithm that gave the computer directions on how to print out a statement just to our standard output here. And we ran that by doing Python 3 and then the name of that file. So main.py, right? So file in this directory and it prints out hello world, right? So this is where we ended up last time, right? So that's review catching us up to where we are now. Are there any questions about the things that we covered up to now? Okay, great. If anything comes up again, as we're going, take yourself off mute, raise your hand, go and shout it out. Let me know what questions you have. Um, from here, I wanted to talk about a few things. So we're going to go directly from here and we talk about this whole files in directories idea. The reason that we wrote this thing into this main.py file and the reason we used the entry point that we're going to go back and look at more and talk a little bit more in depth about is because these things can be called from anywhere. So right now, again, if you look back at our list of where we are now, we are in our home directory. This is, we can prove that by doing the print working directory and it'll show us where we are working right now. And that's our root, home, and then our username, and that's where we are, right? And when we listed things, we have our main.py right here. So all we do is write Python. Now we can call this algorithm, this application that we made from anywhere we like. So if we do cd, which is change directory, and can move from one place to another, and we go all the way down to our root directory, right? So we go cd root, and now instead of the tilde, we have this little slash. If we do ls, we're going to get a whole bunch of other stuff in here because these are all the other directories that are in there. We could still run this main.py file. We just have to give the full path to it. So we can either use the shorthand, the tilde, like we know, and do main.py, and I'm using tab complete to make sure that it's still there. And it should give us hello world just like it did, right? So the idea here is that we know where that file is and we can access it through its path or that full directory, right? We could write it all the way out if we wanted to. If we can do Python 3 / home / my username and then main.py should once again give us the exact same thing. And the reason I'm showing this is I want to make sure that we understand this pattern is something we're going to see over and over again. The Linux pattern of having a slash being the basic part of it, and then some path name, a directory name, and then another directory name, then ultimately the file. That's how, if you look up at the top of your web browser that we're doing this in now, that's how the internet is constructed. It has the same thing, these slashes, and then some location and slash. The URLs that we build when we do our web applications are going to follow the same pattern because the internet is built on Linux and it's nothing more than directories containing files at all points. So I really want to make sure that's clear. Anybody have questions about that? No? All right, cool. So another cool thing about CD, I think we talked about this before, but if you're moving around and you want to go back to your home directory, if you just do CD with no arguments, nothing else, it'll take you straight back there. So now we're back in our home directory. We got a README and our main.py. All right, cool. So if no questions about that, there are a few other things I wanted to go through kind of review wise, but let's go look at our actual main.py file and not work directly in here. We could do this in V if we wanted to. And if you really like that, you can absolutely do that. But for sort of ease of poking around, we're going to open the file in our built-in text editor.
Oh, Jeff,
Yep.
I think that was going to be my question.
Sure.
Like, because I know last time we did the leave out and go into the different console.
Mm-hmm.
Um, and I'm sure you said this, but I don't seem to remember. So why did we do the whole thing where we went through and created the files in
Made
the
the files and the
separate
directories and all that
console?
stuff.
Yeah,
Yeah.
versus in the bash console. I
Yeah.
forgot.
Yeah. So doing the bash console again, it's just this is the really common way to do it, and we're going to end up doing it throughout the class when we start building the application next time. So like all those commands that we do here in Linux are just
Mhm.
general administrative commands that you can do pointing and clicking in some way around using the GUI and doing these things and creating them manually and things like that. You can do it that way, but it's
Mhm.
going to end up being a lot faster, and that's what we end up doing when we're running parts of this are going to
Mhm.
have to go through the command line, right? So all of those commands that I show in Linux and the reason we talk about it are because that's how we're going to be interacting with the code that we write. So it's like administrative computer functions outside of the application itself. Does that answer your question? Or does it make
Yes.
it more confusing?
No, I mean, I guess it does, but I also am still like, I don't know what that means, but okay.
Okay. Okay. Well, so I mean, it's so like, check it out. We have this main.py file right here, right?
Uh-huh.
If we want to make another file and we want to do stuff to it, we could just do that right here. So we could just open this file and start editing and do all the editing stuff just right here directly. And
Mm-hmm.
this is absolutely an option. This is one of the ways that I like doing things. It's a little bit more cumbersome to work with,
Mm-hmm.
but sometimes the absolute fastest way to do it. So it's one of those things I showed you as a trick. It's good to use. I encourage you to do it. But if you don't want to
Well,
and
no,
you
no,
it's
that's not what
tough.
I'm talking about.
Mhm.
Remember last time and maybe this is the same thing. Remember last time we got out of this and we created that?
Yeah,
Oh, okay. So are we saying the same thing?
I think we are. Yeah. So like when we had
Yes. Yes.
this other thing that was just Python, you mean?
Is that what it was? It was
Yeah,
just Python and
yeah,
it
there's
wasn't.
another shell, another interpreter that's just Python itself, right? So this
Okay.
bash, that's Linux, that's all the operating system level stuff. And then
Okay.
Python is like another one inside of that. And it's a really relevant question. If you're not clear on that, it's definitely a good question. So this other one on the inside of it is just Python. So like whenever you write in this and it's got these three greater than signs together, that's a Python interactive shell. And you don't do any of the Linux commands, you do just Python commands. So you could try out
Okay.
Python stuff in here.
But then in the bash console, we can do Linux and Python commands.
Nope, just
No,
Linux commands.
just Linux.
Python command.
Oh,
Python commands won't make sense to it. It won't understand. Like if you try
ah,
writing def something, you know, my whatever, I forget
okay.
the name of this function. It's going to be like I don't know what that is. It's going to say syntax error. You know, and so they're two different things, but they again you interact with them somewhat in the same way, like through the same black and white screen.
Well, I won't keep you on that. I'll just
Yeah.
rewatch
Yeah.
last week's video.
Yeah, no. This is a really good question. Again, we're going to be doing this a couple of times where we're in different environments and we're like picturing these different things. So it's good to ask a question if you don't understand what it is, where it is, and why we're doing it. Definitely ask. We're going to keep building on these things and going further. So if you're confused on something, definitely raise your hand. Did that help clarify at all? Or are you still a little bit
No,
lost?
that makes perfect sense now.
Okay. Okay. Good. Cool. Anything else? Any other questions that came up either about that or anything else before we move on? All right. All right. Cool. All right. So one of
Oh,
the
wait a
places.
minute.
Yeah. Sure.
Wasn't something that you did here? Didn't it end up in the bash console, or no? Or did it end up down here and it looked? I thought it was the bash console.
Yeah. So
Something
that's the
that
thing
ended
is
up in the bash
that
console.
you can run these things directly in here, usually when you're running them, and it'll do something somewhat similar.
Oh, okay.
But that's just for convenience. That's just because it's all built into one spot. But you know, the reason I come back here and run it from Bash is again to hammer home because we're going to be doing this when we do it next week. When we run our Django and the framework that we're going to use, we're going to run it through here and do all the interactions through here, right? So knowing
Okay.
how to do it is important, but it's also to understand again that whole thing that I was just showing about calling this main.py file from other places.
Mhm.
That is an important aspect of what Python does. Well, all languages do it to a certain extent in some way, but it's called modularity in Python, and the way that it works is based on this whole thing that we're talking. So like it is the kind of the focus of the end of where we ended and what we're talking about today. So it's totally an app question. Is that the reason we go to Bash and call it through here is because we're outside of this Python world, but we can run the application. So it's like a connection to the outside world of the application that we wrote. Does that make sense?
Mhm.
Okay. Cool. Really? So what you got?
Yeah, you showed a little shortcut and example for her. What does VI stand for, just for my notes?
So the full name of the text editor that's built in is Vim, VIM. And I forget, it's probably an acronym of some sort. I forget what it stands for. But yeah, it's just a built-in text editor. There's a bunch of different ones. There's one called Nano too that's also usually built in, but Vim is the one that
Text
I'm more
editor.
familiar
Okay,
with. Yeah, yeah. And so all these things like this here is also a text editor, right? And so it'll have certain functionality built into it, like these things that are in blue. I don't know how well you can see it on your screens, but the
mm,
reserved words like def, return, if, print, these are reserved words in Python, meaning that we can't use them for anything else. And the text editor will highlight them in blue. The text editor will give you these row number or these line numbers so that you know where things are, like when an error is thrown, it'll give you the line number where the error was. It'll give you, if I save this, it'll give you these little syntax error warnings before you even run anything.
mhm.
So there's some kind of like common things that text editors do, and they all do maybe varying degrees of that. But the thing that's cool about Vim is it's built in to whatever you're working on. So you could just pop that open. You don't have to like download a separate one or do anything crazy.
Gotcha.
All right, cool. Cool. And again, I know it's like a lot of stuff that we're covering too. So if you got questions about like, wait, where does this fit in and why do we use that? Then absolutely ask. We're going to be looping through and using things several times. So um, go ahead and keep asking those questions. All right. So where we ended up last time, again, we wrote this, what I kept calling an application entry point, right? So this technically is an application. It's got some directions that serve some purpose, even though the purpose is exceptionally simple. But this entry point, I want to make sure that we understand this, is this phrase, this if name with the two underscores equals this main thing. This is what gives Python that ability to call things from outside, right? So when we call it from this bash console and we do the Python 3 main.py call, what it's doing, Python, the interpreter, we start by telling this Linux terminal to use Python to say, hey, go grab Python and interpret this file that we told you to open with Python. And it's going to do the sequential control structure and just read this file top to bottom, left to right, really fast. So that's the first thing it does. And then when it gets to here, it's going to say, oh, if that means I expect a logical condition after this. And so this next thing right here, the double underscore name is a reserved word. It's a reserved variable. We never have to set this anywhere or do anything like that. And it's being checked in a place that we're not seeing it, right? So this whole thing is a convention. And this main, this doesn't have anything to do. I want to be very clear. It doesn't have anything to do with this function name. This is just an example. We could call this something else. We could call this something else. And like again, to make sure we're calling the same function, right? So if we run this function now the way we were, it should operate exactly the same way, right? So the main here in this function name doesn't mean anything. It's not relevant, but this one has to be there. Main is telling us from the outside that this has been accessed from the outside, right? That's what this piece of logic means. And all the parts that are inside of this text, this code block, right? If you remember an indentation in Python, 4 spaces after a colon, 4 spaces is the text block. So this is the part that's going to happen at what's called runtime. So it's going to do these things. It's going to do this function call and do all that stuff, right? Yeah, Aurelius got a question.
So main is the location then. For if underscore name underscore is equal to main, you put it in main, telling it to look for something in this location, right?
Kind of. Basically, this is going to be assigned. This is going to be the title of this file, basically where this thing exists, right? And so what we're doing is flagging this and saying, hey, look, if what you ran is looking for something that's the main thing, this is the main thing. So run
Gotcha.
this. right? And so all that, like looking for the main thing, that's kind of under the hood in Python. You can dig into the documents and read about how it does it. And I do encourage you to like take this idiom and even go over to like copy it over to like Chat GPT or something and just say, explain this to me. Because it's worth knowing a little bit in depth, kind of. But the main thing to remember is that it gives us the ability to access what we write here in this file and the directions that we write down in the file from other places. And the way Python applications are built, and we're going to see this when we run Django, which is the framework we're going to use to build our web application that's written in Python. It's just going to be built in largely the same way. There's going to be one main. It's not going to be called main. It's going to be called something else. Because again, this file could be called something else as well. It doesn't matter what this file is called. There's going to be one main file that does these things, and it'll have in that file for sure this construction, this if name equals main thing. Because all this is telling you is that there's like a Python application here, and this is the beginning file that you need to read and understand what's happening to execute the application. Does that make sense?
Yes.
Cool. Does that make sense to everybody? Because this is a really important concept. This if name equals main modularity thing that we're going to be accessing this file from other files. We're going to do some more examples of it today, so hopefully it's more concrete. But I want to make sure this is somewhat conceptually. Yep.
So you're, it sounds like you said to kind of utilize that because or not because, but it's indicating that the main, I guess, area or whatever to get the actual application, which would be hello world,
Mhm.
is, but I think I'm getting caught up on the hello world.
This, yeah.
So basically what this is saying is, if I don't even know what name stands for anymore, but
Yeah,
if
that's what I'm saying.
one,
It's not pointing anything directly. It's a reserved word that's like written down somewhere else that you have to dig up and find like what it's pointing to.
but I
But
guess my issue is making the link between the if name equals blank or
mhm,
whatever main.
mhm.
I need to find the link or make the link between that and the original def hello return
Yeah,
hello world.
right. So
So,
this right here, again, I'm
mhm.
glad you asked that. So like this up here is again, if we follow the sequential control structure, right? It reads in sequence, and all it does is it reads this and knows that it's there, right? So we're defining this on rows 1 and 2, on lines 1 and 2. So we're saying
Okay.
this is our
So
function.
before you move on,
Mhm.
so we're defining the application on rows 1 and 2.
Nope, this is just one function.
Okay,
We're,
what are
we're gonna
we?
write we're gonna write more functions, right? So an application can have like a bunch of functions that we can
Okay.
write tons of them. We're gonna write 2 or 3 more now
So
and show
what are
how
we
this works, right?
defining then
So we're
on row?
defining again, we're defining that function. So this is called a function. This
Oh,
hello is a
okay.
function, and that's being defined right here, right? And it has a
So
return
the
state.
function is hello,
Mhm. Yep.
and the function hello should give us hello world.
Yes. It will return
Okay.
that. Yep.
So I got that. Now,
Now,
what does the second part have to do with it?
so the second part is when we are out here outside of our little contained my main.py file,
Mm-hmm.
and we're in another non-Python world, we can run that function that we did, that hello function,
Mm-hmm.
by using the Python interpreter and telling it what file to look at,
Which is main.
which is main,
And you
be,
set that up by going if
by putting
name.
this here, yes, because
Okay.
it has this piece in here. When the Python interpreter gets to this line,
Mm-hmm.
it will treat this as the main file of your application.
Okay.
That's what it's doing.
Okay.
Good. Aurelius, what do you got?
Would this live in a proper Python? Like you say, if I go to any Python source and type this in, it will come up this?
Yep. It'll be
Oh, okay.
this construction is definitely in there. Again, I'll show you once we start using um, Django that it's called the manage.py, and we call it a lot the way we're calling our main file right here. But it's going to have the same thing in it. There's going to be a little bit of other stuff in their main file, or like, you know, function, but like this is in here for sure. And this is just like a super, super common idiom. This is how applications are kind
Yeah,
of
I bet.
constructed,
Yeah,
right?
yeah. Okay.
Cool. All right, so we're gonna use this in practice a little bit, and it's gonna be a little more concrete when I show you sort of we're gonna break some stuff out into another file and call it between. But first, I want to go through a couple more control structures that we talked about the sequential, where it reads top to bottom, left to right, and that's just where it begins when you start running. The Python interpreter starts going. It's gonna start line 1, and it's gonna start reading. Remember, indentation is important. The spaces between things, not really. And so we're going to demonstrate a couple other control structures. So the first one we've already done a little bit of is this if. which is a conditional one. So I'm going to put this in as a comment. So anything that starts with a hashtag will not be read by the interpreters. This is for like human notes. You don't want to do a whole lot of them, but you can every now and then. So an if statement is the conditional control structure, and we've already used it here where we check some sort of logical statement, right? So I'm going to put this into a function so that we can continue this pattern of calling it and change how our application behaves. And we're going to keep calling it the same way of just Python 3 main, but the output's going to be different as we develop our application, right? So we're going to change the application by defining more functions. So we're going to define a new function. And this one is going to be somewhat contrived, but it's also kind of going back to a question that you had, Shadiq, when we were doing the math, the real simple math, and you're like, how can we make this where we like have other inputs that go into it? This is how we would do it, right? So we're going to do, like we'll just do compare nums, like compare two numbers, num short for numbers. And we can call this whatever we like. Again, remember the convention is lowercase to begin with. If it's two words, maybe either a space or camel case, meaning capitalize the second one. But typically it's underlined is the more common one. And now instead of having nothing as the inputs, like we did up here on our hello function, we're going to pass it two numbers to compare. Now, these are also variable names. These A and B, this could have been anything. This could have been X and Y. This could have been first number, second number. This is just telling our definition, our function, to expect two things as inputs. Right now, we could tell it what kind of inputs to expect, but right now it doesn't really matter. There's just two things. We know that they're going to be numbers, but we're gonna move forward with doing something with it now, right? So we're doing conditional control structure. We're going to use that if statement again. We're just going to write it directly in here. Right? So we say if, and we're going to use those inputs that we have. So we say if A is larger than B, we're going to do something. Again, this colon, once I hit enter, it moves in two indentations. So that's 8 spaces over. And that's where I am now. Remember, Python doesn't really care about some of the spacings, but the indentation is really important. And so then I'm going to return something. So I'm going to do just a string that says A is greater than B. Close the string off. Great. So that is handling one case of the logic. Now, obviously, that's not the only scenario that could be. It could be the B could be larger, right? But they could be equal. So there's at least two other things we want to do. So when we have a case like that, we want to put in further steps of logic. What we're going to do is we're going to say elif. So that's short for else if, but compacted to one word. And as you see, all the highlighted blue are reserved words. So elif, and then another condition, right? So let's do, just keeping these pointing the same direction. We could do if A is less than B. This isn't a logic class. It's more about the syntax. So same thing. We're just going to say that if B is greater than A, to return a statement that says that. Now, the way this is going to read is when we call this function and give it two numbers, the computer's going to take those numbers and assign it to A and B. And remember, assignment means that it's setting aside some memory space and labeling it whatever we tell it to, labeling it A, labeling it B. And then it's going to compare those things. And this first one, it says, okay, is this condition met? If the condition is met, it will enter this code block and return this. If it is not met, if this condition is not true, it'll skip this code block and go down to 8 and check this condition. If that one's true, it'll enter 9 and do this. If that one is also not true, it will move on to whatever you have next, right? So if you have nothing next, it'll just stop and tell you nothing. So the end case for these if conditional logic statements is just else by itself. And this is called the base case, called the catch-all. It's sort of what's going to happen if neither or none, because you can have multiple elif statements in there if you want to. You can keep stringing these together as long as you need to, really. I mean, at some point, if there's a lot of them, you may want to rethink your approach because it might be bad logic, but I don't think there's a real hard restriction on how many you can use. But the last one, you generally want to put in else case. Yeah, really. So you got a question?
Maybe the acronyms are throwing me too much, but what does
Sure.
ELF stand for?
elif. So that's short for else if. It's just ELIF. Yeah. Yeah.
Okay.
And so it's this is basically like, again, if you kind of read it almost in natural language, you say if A is greater than B, return a string that says A is greater than B. Else if B is greater than A, return a string that says B is greater than A. Else return,
Copy that.
A and B are equal. Right. So this is really just saying, if this condition is met, do this thing. Otherwise, else if do this other thing. And then in the very last case, do this thing. Go ahead, Aurelius. What question you got?
No, I just didn't lower my
Oh,
hand. I'm
didn't put it
sorry.
down. Okay, yeah, okay, cool. Does that generally make sense? Anybody got questions about how we put that together and the conditional control structure of the if, elif, and else?
At any point during these strings would parentheses matter? Um, I know up top when we use def, we were utilizing the parentheses, and that and that was to form our basic. Or like I'm a little bit not confused, but would those matter at all? Will we be using parentheses again at some point?
Yes, that's a good question. So up here, when we define the function itself, the parentheses are going to tell us like the input space basically. So this is for whatever inputs we're going to put in. So in our first function that we did, there were 0 inputs, so it's just empty. But functions always have parentheses. You notice when we called our function last time, we had to use the parentheses again. So typically, I mean, unless you're using, again, if you remember that somewhat rarely used tuple data type, um, you're not going to need these again for anything. I'm not sure I'm answering your question though. Is that answering your question?
Yeah, that's answering my question. Yeah.
Okay. Okay. Sure. All right. Aurelius, you got one?
Yeah, is there an and then state? Because I get the concept, definition, compare numbers. If A and B return, A is greater than B. If B is less than A is return B is, or B is greater than A,
Mhm.
and vice versa. But is there like and instead of else if?
Um, no, but you can put multiple conditions on one line, right? Like you can put and, you know,
Mm,
A is greater than 100 or something like that. Then
copy that.
you can make that and you can string those. Um, and you can put like not is also a reserved word. So you can make your conditional statement itself, the logic there, a little bit more complex and add like ands, and I think or is also available in there. And you can do some more within the actual statement. I'm
This
keeping those kind of simple, but I think that's where you'd want to do those.
this just got a whole lot simpler.
Okay, cool. Cool. All right. All right. So then what I'm going to do is I'm going to show that so let's just do this as an example that it works. I'm going to test it out, right? So we're going to go down here in the bottom, and we could run everything just through main and keep that just one call down here. I know we changed it to hello, but instead, I'm just going to copy this and run it directly in the bottom. Hold on, I'm gonna give us some space here. Move this up a little bit. And I'm gonna run everything down here again, just to really kind of hammer home that every time we call this file from outside of it, it's going to enter this code block and do what's inside of here, right? So like, I really want us to focus on this is what's being done here. So when you write your own programs, there's a number of ways you could put places. We might start doing some things today called refactoring, where we move stuff around and it doesn't change the function. But for now, this is one way we could do it, right? So we're going to stick with this pattern. And so instead of passing variables, we're going to pass real numbers this time, right? So we expect there to be integers, right? So if we say 5 and 8, we expect A obviously to be larger. I'll do a couple more, and we could call these test cases if we wanted to. But let's do, I don't know, 10. Wait, A was small in the first one, so we should make A larger in this one. 10, 2, and then make these the same, right? So that's three possible scenarios. And when we save this, now if we go back again to our bash console and we run it just like we did before, instead of saying hello world, it should give us the outcome statements for the output statements for compare nums these 3 times that we run it, right? On their own lines, because that's what print does. So I'm just gonna hit up back in my bash console to get back to the last command that I wrote, because it was calling this file. Hit Python 3 space main.py. When I hit enter, then as expected, we have our output based on the logic that we built and the input that we passed it. So that is real quick, real basic example of conditional control structure with the if, elif, and else statements.
And so if you had put numbers that didn't make these things true, would it have given an error message or would it have not printed anything at all?
Let's try that out. Let's try putting the string 5, because as you recall, we can't compare numbers and strings, right? That usually throws an error. So what do you expect to happen on this first one? Knowing that that's the behavior normally, what do you think is going to happen?
Wait, and this is if A is,
So this is a string, so it's not a
oh,
number.
oh yeah, because it's in the,
Yeah, we could do this
I don't
to
remember.
make it clear that it's a string. That's cool. So
No,
like, let's
I'm
say,
trying
so
to
let's say,
remember what the string is now.
yeah, string is anything within quotation marks is a string. So it could be special characters, it could be letters, it could be numbers. It doesn't. The computer doesn't care. It
Oh,
treats this as something different. It doesn't understand it as a number, even if it is a number.
so it wouldn't, I mean, so it's not an integer, so I don't,
No, it's not.
yeah, so I don't know. I guess it would give an error message. I don't remember what happened before.
It's a good guess. Let's find out. Yep, error message. So type error. So this logical operator is not supported between instances of string and int, right? So that's telling us that the first thing we gave it was a string, and the second thing we gave was an integer, and we can't compare those. So that is what would happen if we have invalid input.
Okay.
And that
I
also,
gotta,
kind of highlights when we talk about debugging and things like that, is that these are the sorts of things that once you find that, you're like, oh, and then you have to rewrite your function to handle that sort of thing and make sure that like everything that's passed to it is something that could be compared. Something could be an integer. If not, throw it out. Give the called error handling. It's kind of tell users something went wrong without breaking your program, if possible.
And I have a quick follow-up. I
Sure.
know Aurelius has his hand up.
Yeah.
So, and this is really remembrance.
Sure.
And so you said, unlike Linux and Python, if you just replace the function or whatever, then you don't have to go back and clear everything that you did before, right? Isn't that right?
No. Yeah, you don't. I
Okay.
mean, yeah. So if you talk about it in the terminals, they operate a little bit differently. Yeah, you don't clear.
Okay.
You can clear the Linux terminal, which I like to do. So, Relis, you still got a question?
no, I just figured it out. I had an arrow in mind, but I think when I when I went to print, I said compare numbers A and B, and it gave me an error saying A wasn't defined. So I just
Yeah.
went in and put in some random numbers, and then they said A is greater than B now.
Cool. Right on.
So you just had to change the I'm bad with definitions, but
The input.
yeah, or the inside the quotations. You just had to change that up.
Yeah, you mean inside these parentheses right here?
Parentheses.
Yeah. So like when we define it up here, we use variable names A and B, and then when we call it, we have to give it real values of some kind
Mm-hmm.
because those variables don't exist. This indentation I keep mentioning is how Python controls this concept in computer programming called scope. And so what we're doing here is telling it that within the scope of this code block, what this colon is, we have these things A and B. It's like we've defined them here. We're going to use them here and do things with our logic. But now that we're down here, this is a different scope. It's like we're outside of that. So A and B don't exist here. Like A has no meaning. You can't use it. You'd have to define it again into something else. So it's contained. These variables are contained to this function right here, which I can collapse here and break down. So like it doesn't exist outside of this. Does that make sense?
Mm-hmm.
Cool. All right. So if any other questions come up, please absolutely shout them out. We're going to move on to the next thing that I want to cover, which is the what are called iterables. That's kind of a terrible name, but anything that can be iterated through. So the collections that we talked about when we talked about data types of lists and dictionaries are iterables, as well as tuples and sets, which I said we're not going to use as often, and we won't. But list, dictionaries, sets, and tuples are all things that you could take each item and loop through and do something with them, right? So operations on iterables, which I think I spelled that right, but who knows, are called conveniently loops. So there are a couple of kinds of loops that we're going to talk about. They're very, very handy. And when we go to write our own algorithms, this is what makes it kind of interesting and make it do something more than just a simple math operation or simply returning a statement. This is going to do something repetitively over and over again for everything that's in a list, or do something a certain number of times. And all that kind of stuff is going to be done with loops. So the first kind of loop that we're going to talk about is called a for loop. And this is conveniently using the word for. Just like always, we're going to wrap this into a function because we're going to get in the habit of doing that is getting muscle memory to put our functions, our functionality into functions. And since we're going to be doing things with lists, I'm going to use an example of just show the items that are in a list. So we'll say show list items as the name of our function. And it's going to take, again, this is an arbitrary name. I didn't use the word list because it too is a reserved word, I'm pretty sure. But ls, short for list, is the thing that this is going to expect in. And if you remember, it's square brackets, 0 indexed, right? That's the list, or an array in broader computer programming terms. But in Python, they're called lists. All right, so the for loop, what we're going to do is conceptually, we're going to take this list of things and we're going to grab each one of those things and do something with the thing, right? So imagine we got a whole list of phone numbers and we want to go through that list to pull out each phone number and add it to another list that we compile everything together. We have like 6 lists of phone numbers. We want to put them all together, right? So we want to go through each list, stick it together, or something like that, right? The way we do this is with the word for, and then we're going to use another variable name. So we're just pick another name for whatever we want to. This could be a single letter. A lot of times people just use I because it's the thing that is going through this iteration, right? So the actual thing. I'm going to be a little bit more explicit and say item. So for item, and then in another reserved list or word in our list. So for item in, and then the iterable. In this case, our variable name ls that we passed before. So this is the for loop construction. The for variable name that you want to in the iterable list, dictionary, set, tuple, whatever it is you want to list that you want to go through. All right, and when I hit enter on this, it's gonna go in another indentation. So I got eight spaces over. And I'm gonna tell it what I want it to do. So because we're just demonstrating, what I want this to do is I want it to print each item. So each time it goes through this list, it's just going to print out to our screen, our console, the things that are in that list. That's it. So we could have this do math. We could have this do any number of complex functions. But for now, just to show how this works, we're just going to have it print each thing that's in there. All right, and that's it. So this is a for loop. Very simple. Let's go ahead and demonstrate this. So I'm going to take this down here. And since we have a print statement inside, I'm not going to wrap it in these print statements like we have in the past. But we need this to exist. So I need to declare a variable. We're going to call this my list. And if you remember, lists have square brackets, opening and closing. And then we just put some things in here. So we put integers. We could put strings. We could put other lists. Doesn't matter. We put dictionaries. Makes no difference, right? So now we have that thing, my list, here on row 21. So on line 21, when we call our application, it's going to make this list for us with this information in it. And then down here, I'm going to pass that variable my list as the input to our show list items function that we defined up here, right? And it's going to go with our for loop, grab each item in that list, and print it. Right? Everybody tracking here? All right, so now when we run our command, like we did before, same thing, I'm just pressing the up arrow to get back to my command in my bash console. I'm going to run my main Python application. And this time, as you see, it just listed out on each row itself, each of those items that was in our my list variable right here. So 5, 6, the string, and then the list 1, 2, and then nothing. So just the 2 item list right here. Now this kind of violated a principle that I've said functions need to return something. But if we did just return here, it would break on that first one. The first one that came through would come through and just break it. So we want to do this on every time, and we left the return statement out. So as you can see, that won't break anything on the interpreter side. The Python interpreter will read a function that doesn't have this return statement, but it'll be kind of useless to you if you don't kick something back out to yourself, right? So this is giving us something in lieu of a return statement just to be demonstrative. Any questions about this construction, the for loop? Yes, Aurelius, what do you got?
What was the bash console control? Command, to pull this up.
So there's just
Python main
the same thing, yeah, Python 3 space main.py. And that should be the only command that we're going to run for the most part in bash today. Alex, you got a question?
Yeah, so what's the main reason that you're not using the print statement inside the function if our goal is to print something?
Not, oh, if I'm not using it down here, you mean?
No, inside a function, you said usually you always return something instead of a
Yeah.
printing.
Mhm.
Yeah. So if our goal is to print the item, why not just use a print function directly inside a function
I get what you're saying. I
instead
get
of
what you're saying.
returning?
Yeah,
Yeah.
yeah, yeah. I get what you're saying. So, because
Is there any different?
yeah, there really is. So more often than not, when you're writing an actual application, you're going to be returning things, and you're not going to see anything. It's going to go like one function is going to kind of feed into another function or write into a database or something like that, right? And you're going to be using return statements to do all of that. The print statement is just something for our convenience and like as developers to give us some kind of information about the
Mhm.
application that we're doing. Does that make sense?
Yeah. I
So
just wanted to know the difference why
yeah,
sometimes we use a print and sometimes we use a return.
right. Yeah, yeah, yeah. So more often than not, you're going to be doing return. And print
Oh,
itself is just a built-in function that makes something come out on the screen like for developers to see. So like usually you're not going to write a full-on program where this is all anybody's looking at. And so you're not going to use
mhm.
print a lot in an actual, like you're going to build, and when we go and build our web application, we're not going to be printing anything out to this. We're going to print it out to like a web page. You know what I mean? So,
Yeah, yeah.
so we're not going to use print. We're going to use returns.
All right, thank you.
Yep. Sure. Good question. Any other questions?
So could print or is print kind of used just to verify that what you're putting in you mean to put in?
Yeah, it's a good debugging tool. It's one of honestly, I hate to admit it, but it's kind of like one of the main ones I use. That as you're writing more complex algorithms and functions and things like that, you know, you'll change variables a couple of times and you'll move lists around, you'll reshape stuff and change it, and sometimes you forget what it looks like. And so it's good to drop that in there and just print it out and say, oh yeah, this is what it's supposed to be, or I expect it to be a dictionary, and there's nothing. You know, like it is helpful, but it's to answer your question, it's mostly helpful for developers and people that are going to be working at this level of things, right? You're not going to generally have this planning for end users to see. Cool. Yeah, really. So we got, man.
I think I'm getting a pretty embarrassing error here. It says indentation error. Undent does not match any outer indentation level. And I checked all the indentations. It was all the same.
So you might be missing a colon somewhere.
Oh,
But that's usually what that means is that if, you know, and on this for loop one, keep in mind that the print statement is two indents in because there's one for the function itself, then one for the for loop.
mhm.
So it's two indents in. But that just means that there's somewhere where there's either a colon and then there is an indent or there is not an indent where there should be. But yeah, if you keep getting stuck on that, man, I can help you out looking at it after class, but I'm gonna press on.
Mhm.
Cool. All right. So the next kind of loop that we need to talk about is a really fun one, and you know you do some pretty cool stuff with it, but it's also dangerous, right? So it's good that we're doing this in our browser. If you're doing this on your home computer and you're not doing it in Python anywhere, just caveat: this is something that can eat up your CPU power and like crash your computer, right? So it's called a while loop, WHILE, and this is basically going to do similar to a for loop where it does something for each item that's in a list, but then it also captures some of the logic of this other control structure, of the if control structure, because it's going to check how true or check a logical statement. And while that statement is true, it will do the code block that you give it, right? That's what a while loop does. So to do an example of how a while loop might be used, let's do another function. So we're going to define a function, and let's imagine that we have a container, like a box or something like that, right? And it's empty, and we're going to put stuff into this box automatically, but we want to make sure that the box doesn't overflow. We can't go over a maximum amount in this box, right? So we're going to call this just a container filler is the name of our function, and we're going to give it a maximum amount, right? So we're going to give it some kind of number that says you can't go over 20 things in this box, whatever that thing is. But the box can be different sizes, so the maximum can change whenever we call it. All right. So that's our sort of imagined scenario. We're filling up a box. Now, when we do these loops, what we're going to want to do is we're going to want to, each time we go through, change something and then check that thing to see that it's changed and make sure that it does, you know, fit into our logical scheme, that our logical statement makes sense. Because if nothing changes once we enter our loop, we'll never exit the loop. It'll go through an ongoing loop, and I'll show you what that looks like. But for us to do that, a very convenient thing is to just set a variable. I usually like to do count, And we change that each time the loop goes through, right? So what we're going to do in this kind of conceptually before we start writing the code, I guess, is we're going to take the maximum number, say 5, and we're going to take this count, and imagine count as we counted the things that are in the box right now, and it's empty. So it's going to start at 0. So count starts at 0. We open the box, there's nothing in the box, right? And then while, how's our loop, while that count is less than our maximum, right? You see how Python kind of feels like English almost? We just pretty much said that out loud. While count is less than maximum, do something. Do this code block, right? So now we've entered into another indented code block. So we're 8 spaces over. And so now we've checked our logical condition here. It says count is less than maximum, which the maximum is what we're going to pass it when we call it. So again, if we're imagining, say, 5, as long as this count is less than 5, we know that the first time it comes in here, the count is 0. So nothing has happened. So what I like to do when I start out here is change that first. If you forget to change it and it doesn't change, it's always 0. This loop just keep on going, right? So the way we change things, the way we change, especially into integers, numbers, things like that, we can increment and decrement by using the plus and the setting. So basically, we're taking count and we're adding and then setting it back to itself, right? So we're do plus equals is the way it's written, but it's that equal sign again doesn't mean equals. We're setting it, so we're saying add 1 to itself and then put it back in this same name, right? So count plus equals 1. We'll increment the count by 1. So on this row 23, this line 23, count becomes 1. Great. So now if maximum is 1, it should break right there. But we want this to do something to let us know that it is actually operating. So we're going to give, like we've talked about, a print statement out, right? So this could just roll up and finish and not tell us when it's done. But we want this to print something out each time that it does this to tell us that it's added something to the box. Right. So I'm going to introduce you to another thing that we're going to use in the future. And you're going to see a lot of places. This is called a formatted string. The way we do that in Python is just the letter F and then the beginning of a string. So either the single or double quotation marks, either one works in Python, if you recall. And I'm going to close off a print statement. And then inside this string, I'm going to show you what formatting does and why we use it and why it's cool. So we could put our string. So we say the container has, and now we can use our variables that are inside our scope here. So remember, our scope is this whole function. So any variable that we've got in here, like count, that's one we can use. So we put that variable name inside curly brackets, just the variable name, count. And then finish up our sentence. And what this is going to do is as it adds items to our imaginary box, it should print out that the total number that is then in that box, right? And so that's a while loop. And so this should stop once this number is not larger than that number. It should break and no longer continue. If we want to do another statement that said, hey, we're done filling the box, we could put that outside of this while loop somewhere down here, right? So like, the box is full. And that should print only once the box has been filled up. Right, so that is an example of a while loop. Let's try it out like we have with our other things. So again, I'm just gonna do, I can just copy this and we'll replace this with our container filler, but we're gonna do 5 as our maximum. Let's hit save. Now if we go back to our bash console and run it like we have everything else. And there we go. So now I ran it each time. It added 1 item until there were 5, and then it said the box is full. So that is an example of a while loop where it checks the condition. As long as this condition is true, it will execute this code block. And one caveat, make sure that when you do these sorts of things, you keep in mind where you put this adjustment, the change, right? So if I move the count to after the print statement, this is going to give us an example of our off by 1 error. So now if I run it, see the first time I went through and it added something that says 0. And now at the last one, it says there are 4 items in the box because the first time it went through, we did the print statement before we counted up, before we added something. So the count was still 0 on line 24, right? So now we are off by 1. So we're saying the box is full, but it's only got 4 things in it, right? So that's an example of how off by 1 errors can happen. And it's quite literally just where you put these things in your code. Any questions about while loop, for loop?
So you went down. All right. So if name equals main, and then contain filler 5.
Yep. Yep. So this is just calling that function that we defined and giving it some real value, which, you know, again, could be anything that we wanted to. It should work the same way.
Say.
I can move some of this space up so it's not so far away. All right, cool. So those are the main things that you need for writing your own algorithms and solving problems with them and writing applications and stuff like that. Aurelius, you got a question before we move on?
Is there a way to change the margins? Like I keep trying to go down and it just slightly off where it should be when you tab over,
Huh.
and I'm trying to put it in a proper place, but it's not going there. It keeps going into this error margin.
Uh, that I don't know, man. You might have to refresh your browser. I'm not sure if there is a setting in here. I've never really messed around with it on the Python Anywhere side, where if there's like a setting to adjust how far things move when you hit tab or whatever.
Thank you.
Yeah, yeah. But if tab itself isn't working, I say just use the 4, you know, hit space bar 4 times, and it's going to be the same amount of space, right? So, and I think that just did make it automatically tabs for me when I did that, because this forces it to tabs. But yeah, that's a pain. If you're running that indentation error, it's really annoying to find. I agree. All right, cool. So if we don't have any questions about this, that is the last thing that I want to do with functions for now. And I wanted to spend some time talking about the last data type in Python, which is really cool, but it's a little bit complex. So I want to make sure we had plenty of time to talk about it. I want to try to jam it into the end of the day last time. And it includes a lot of things that we've done here. So, you know, it makes sense to do it after these things. But these are called classes. Now, classes in Python are a little bit slippery of a concept, but again, it's very, very important to understand about Python and how it works, because classes are everywhere, and we're going to be using them next couple of weeks as we go. So we're going to get hands-on with them now, describe what they are. But if you feel after today that you're like, I don't really get classes all that well, don't sweat it. It takes a little while. It's not a big deal, right? But so this is kind of the first introduction to it. We're going to go through it. To do that, we're going to open another file. So we're going to create another file from here. So I'm going to go back to files. I've saved this. I've saved my main.py. We'll come back into this, and I'm going to show the file that we're going to work in, plugging into this one, right? So let's make another file first. Let's go back to our files. And again, we could do this in the bash console. We could just write v and make our file. But for those of you that prefer to do it here, we could just go right in here where our main.py file is. It says files. It says enter a new file name. Like say hello.py. And we're going to do classes.py. And this is going to be a place where we keep our classes. And when we hit new file over here, it's going to take us straight into our code editor. I probably have too many bash consoles, so it's not going to open down here at the bottom, but that's fine. We're going to run it directly out of our bash console like we have. All right, so the first thing we're going to do, just again, to maintain the habit, we're going to do the if name is equal to the string double underscore main, so that we can call this directly. So we're going to call this one directly for the beginning, just to kind of show how classes work, and we're not messing too much up with the other thing. And then we'll talk about modularity and move this into going through the main file as a separate step, right? So right now, let's just do this as a thing. This word pass is a placeholder until we got something to give it, right? So right now, pass, to make sure this doesn't break. If we do call it, it's again a reserved word. This is a way that if once you start writing things, if you're defining a function and you do a code block like this and it expects something after it, you could put this in here as a placeholder so that it doesn't break if you run this now. Like, it'll still work, right? Okay. So we have our main call, our app entry point, so we can call this classes.py directly from the bash command line like we did before. And now let's define a class. Let's do some stuff with classes. All right, so when we define functions, we use the reserved word def. And when we define classes, we're going to use the reserved word class, which is convenient, easy to remember, lowercase, CLASS. Now, when we name classes, the convention is to put them uppercase. So capitalize our classes. Before we start defining class, I should take a step back. Sorry. So classes generally are like a template for an object, right? So they're more complex data structures than the other things we've talked about. The example we're going to do is a car, right? So think about a car in the world, right? When I say the word car, you're probably thinking of like most likely a four-door kind of sedan thing. You probably didn't think of something that's got 3 wheels. It's probably got 4 wheels. You probably weren't thinking of a truck, like a big semi truck. And that example you have in your head, even though it's not one concrete car, that's what a Python class is. So Python classes can be used to make instances, as it's called, a specific car, right? So there's an example car, it's got 4 wheels, but then think about like you probably have a car or you've ridden in a specific car. And that car had specific stuff about it, like a make, a model, it had a year, right? But those terms, the make, model, year, that applies to all cars. So a class in Python is the template that kind of applies to a bunch of things. And we use that template in a program to make more of those things. Is that generally making sense? It's going to make a lot more sense if we start using them. But anybody got questions before we go on? Like, is that definition totally losing you?
So you said, so pretty much classes to identify a main thing. You use you're capitalizing them to like define different things, right? Like
Yep.
one class. So it's
Yep.
like subclasses under the main class. Right?
Exactly. So it's not quite, yeah, exactly. So what we're going to do is define this main class and give it a list of all the things that exist in that thing. And then we can use that main one to, like you said, kind of inherit those things that we tell it exist in there, right? Like, again, all cars probably have doors and windows and stuff like that. And then we can start saying what kinds of doors and windows, like what kinds of tires, all those sorts of things, right? So that's what Python classes can do. We use cars as an example, but we could do any category really. Like you could define an animal class or, you know, a bank account class or something like that, right? Or a user class is one of the ways that we're going to do it when we do classes in our web application. The way we define our database is going to be through classes. We're going to define each of the actual pieces of our application that we want to use and reflect something in real life. They're going to be described as classes. Making sense? Cool. All right. So again, it's going to make a lot more sense as we get going with this and get a little more hands-on. So let's start defining this. So this right here is the very basic definition of a class. So it's capitalized, right? You use the word class, space, and then a capitalized word. Similarly, if we wanted to do some other words, like, you know, if there's 2 words to this, we would capitalize the second one as well. But for now, we just got car and that's fine. And then just a colon. So no parentheses. Those aren't required on this. And then inside of this code block, right? So indentation again, 4 spaces, just like always after a colon. So inside of this class definition, we're going to give it what is called attributes. Now, attributes look just like variables. They're just a word, lowercase word, and then an assignment operator, and then a thing, right? So we talked about cars have, let's say, a make. So we can just call that a make, and we can set that to what the make would be, right? Now, this, again, is the template. Not all cars have the same make, but we expect it to be a string. So we'll just give it an empty string as a placeholder for now, right? So these are attributes of a car. Do make, model, let's just do year. Year we can set to a number. Just say 0, right? Okay, so this technically is a well-formed car class. Now, what do we do with this? Do something with it. Now that we have this definition up here, when we call this program, what we need to do is what's called instantiating a class. So now we have this definition here. To make a single car that has a specific make, model, and year, we have to make an instance of that class. And we're going to store that in a variable, right? So if we're going to describe, let's say, my car. And so we will do capital CAR, and then open and close parentheses. This line right here has now created in memory a car object that has a make, a model, and a year, and it's called my car. Now we could check this out. We could say, you know, look at the things that are in there, but they're empty. It's just going to be empty strings. It's not going to have a model, make, year. Year's going to be 0. So for it to have any information, we have to set those things as well, the way that we set this. And we call things inside of a class, my car, using what's called dot notation. So we do the name of the class or the name of the instance of the class, right? So on this line, we created one. We created our car instance. And now we're going to say we want the make to be something. So we do car dot whatever attribute we want. And then we set that attribute. So we can set it directly the way we set a variable. So let's say we want to make this a Chevy, and we'll just put in the other stuff, model. So this was my first car. It was an awesome chunk, year, and well, I'll just put I'll put this as a number. Okay. So now we have passed it these attributes. We've told it this car exists. We've defined our car class. We've instantiated it. And then we've set each one of its things to be something. So what does that give us, right? So we have this car. Now let's give us something out to show that we've done this, that we've made this car, right? So we're going to do a print statement with a formatted string. And it's just going to have, it's like, say, the convention of year, make, and model, right? When we talk about our cars, we say year first, then make, then model, typically, right? So I'm going to say, we'll act as if this is the car talking about itself. I'm going to use double quotation marks, and we'll say, I'm a year, right? So we should expect 1987 make, and then model, right? That's how we called it before. Except this time, because we're calling from a class, we have to make sure that we're calling it from the class. This make, model, and year, these aren't existent everywhere. They're parts of this. So we have to use the same dot notation to call them. So my car dot year, my car dot make, and my underscore car dot model. Close off this string, close off our print statement. Okay, so what this is doing is, again, we've defined our car template with empty placeholder information. Then we've instantiated it, and then we've set each of those variables, those attributes, and then we're going to return ourselves something that says this is what we have, right? So when we save this, we go back to our bash console, and this time, instead of writing main, we're going to write the classes that we just made file, and we should get a string that says, I'm a 1987 Chevy Celebrity, which is what we set it to. So this is what classes do. This is a very, very, very basic, like that's what classes do. That's how classes work. You can define them as a template, and then you can make as many of these as you want to, right? So you can make your car and Steve's car and Aurelius's car and any number of cars that you want to off of this one class description, this one class model.
And if you wanted to make it other cars, do you have to do the same thing under the if name situation, or is there a way you can like
Do it faster and not have to write all these lines?
Yeah.
Yeah. I love it. That's a great question, because yes, there is, and we're going to get into exactly that now. So I love it. Your question is always like one step ahead of where we're going. But this is kind of the most explicit way of writing each step all the way out. So what we're going to do now is we're going to refactor. So I mentioned this a couple of times, and we're going to do it throughout the course. Refactoring generally is rewriting your code so that the function doesn't change. So it's going to function exactly the same way every time if we don't break anything, right? So each time it's going to spit out this string, and it should be roughly the same unless we change something and break it. But we're going to rewrite the way this is written. So it's either, like you said, Shadiqua, it's less lines of code, so it's easier to maintain because it's all in one line. There's less to write. It's easier for humans to read. Those are kind of the reasons we will refactor. So let's go through some of those now and see some of these handy tricks. And I'll also talk about the other thing besides attributes that's very important about classes. That's called methods. So method is going to be the first thing that we're going to do. So a method of a class is a function. It's just like a function. It's written like a function, except it's inside a class, right? So attributes are just like variables, except they're inside classes. Methods, just like functions, but they're inside variables. So right here, we have this print thing that says what it is. I'm a 1987 Chevy Celebrity or whatever make, model, year, right? Year, make, model. I don't want to write this every single time, like Shadiqua said. I want to be able to do this, like each car is going to say this, so I don't want to write this 7 times if I want to make 7 cars. So what I want to do is define a function that will do that for me. So inside of our car class, right? So we're spaced down a little bit from year just so it's easier for humans to read, but we have one indentation, so we're in the same scope as our car class definition. We're going to do our old familiar def, short for defining a function. We're going to define a function. And we'll just call this display details, because that's what it's doing. It's going to display the year, make, model, right? Details of the car. And imagine this is, you know, when you look at a car, if you know how to see it, this is what you see when you look at the car, right? Except it's actually saying it to you in our program because we can't actually visually see the car. All right, so in this function, because it's inside of a class, there's always, when you define the method, a method inside a class, again, this is what separates it from a function, you have to pass it the word self. It always takes that one input. If you forget self in a method, it's going to break. It's going to be like, that doesn't work. The reason it does that is because this method is going to work on itself. It's like referring back to this thing, right? So all the stuff that it does in here, it's kind of doing internally to itself. So self always has to be put in there. You could put more things in here if you want to, but this has to be there in a method. All right. So this is the basic display details. We tell it that it's a self. And then what we're going to do is we're going to take this print statement from down here. I'm just going to Control X, copy it out of there, cut it out of there, and then paste it up here. Right? Just move the whole thing up, right? And that is the first step of refactoring. But what else needs to change? Before I change it, does anybody else see what needs to change before this is going to work?
My car, make, model.
What about it?
You gotta actually put it inside a car class.
Okay, close. You're talking about here or here? Which my car are you talking about?
The one inside a method.
This one right here? Okay. You're right. You're right partially. This is definitely the thing that needs to change. What about it needs to change?
So, inside the if name equals main, the bottom.
Nope.
Whatever
nope.
you
No, go ahead. I mean, I was gonna say, yeah, like it's in the right place relative to everything. So this doesn't need to be in there. It needs to be inside of our car definition. So it should be here, but it does need to change somehow. You're almost there. You're close. Anybody got it?
The actual variables, I guess, or yeah, like, don't you?
You're right there. Yeah, because this is referring to a variable, right?
So you have to have the information, like
Exactly.
what kind of car, what
year,
model.
make, and model.
Yeah.
Well, nope, not that part.
Oh.
So not quite. You guys are really close, really close. I love the way you're thinking about this, right? So this my car is referencing this variable. It's not defined until here, and it's in a different scope, right? So this scope inside car has no access to this variable. So this isn't going to work. It's not referencing that though. It's referencing self. It needs to refer back to itself. So it's referring to its own year. And this is what makes it generic, right? So each instance that you make, like when we make an instance down here on line 12, it is making a self. It has now made a self called my car. And now my car itself has this method display details. And it will refer to itself, its own year, its own make, its own model, right? So that's the only change we got to do. So now we have a method that should refer back to itself. And we could call that, leaving all these things the way they were. We're going to refactor this in a second. Should equal, so just one step at a time. But we're going to, underneath these, we're going to keep these statements, the instantiation on line 12, and then setting the attribute values on lines 12 or 13 to 15. Underneath that, we're going to do my car, same way with dot notation to get to that method. So display details. And because it's method, we got a parentheses. Right? This doesn't take any inputs. We don't have to give it self. The self is implied with the dot. So the dot tells it that self should be there, and this is the self that it's referring to. So now when this runs, my car with these details will be the self when we run this. Okay, so that's the first refactoring. What we did is we refactored this print statement that had been separate out here into a method that's now generic. So each time we make a car and we add details to it, we can just call this display details and it should print out the same. So this should go exactly the same way. When I hit up and just do Python 3 and I call my classes.py, and it does. It says I'm a 1987 Chevy Celebrity, just like it did before. So that refactoring didn't change anything. It just made our code easier to maintain. It's in one place now. We don't have to write several print statements. We just have to call it in one line like this. Cool. Everybody tracking on that so far?
Yeah, and if we want to change it, can we just jump into that line and change Chevy Celebrity 19? 1987 into
Yep, you
whatever
could
you want.
change these things to whatever. Yep, you absolutely
Okay.
can. And then we're going to take this a step further to where we could compact these 3 lines of code into things that we could just pass right here when we instantiate it and make it just a little bit less to write using another method that's very common. So this is something that might be, I was on the fence about including this generally in like a beginning course, but it's something that you see so often, even if it's not one that you're real comfortable writing, you see it so much that I want to make sure that we cover what it is and how it works, right? So it's another function that we use generally when we to initialize the basic parts of a class. So it's called another reserved word, double underscore init, INIT, double underscore. And this is short for initialize, very common in, let me give some more space. We're all packed up. Real common in computer science stuff to initialize things. You'll see this init, double underscore in Python and a couple other places. But this right here is very common to set this method in any class that you make and put all these kinds of things inside of it, right? So these attributes and set the attributes in here so that you can pass them in a much cleaner way. You don't have to explicitly write each line and know each attribute that you want to set and things like that, right? So we're going to take these attributes. Again, this is refactoring that we're doing, right? So we're going to move stuff around. Functionality is not really going to change at the end. So I'm going to take these things. I'm just going to exit out, Control X, copy or cut, and paste it inside. Make sure my indentation is right. Should be indented 2 spaces because I'm inside the definition. Now we don't have any attributes in our class. We just have methods. I've moved our attributes into here. So these are our attribute calls. Now this doesn't do a ton for us because right now it's just calling them into the same thing. It's calling us into generic empty strings. So this isn't saving us anything. We're not doing anything differently. What we need to do is we need to, in this initializing function, pass it some more arguments, is what it's called, right? So more things inside of here that will tell it that it can expect more input at the time of instantiation. So down on this line, right? So I'm going to show you 2 conventions on how to get these things in there. It's the best way to do it, generally speaking. 2 approaches, and then I'll explain why we would use one versus the other, what the difference is. But these again are very standards. You can look them up a little more later. But they're called arguments and keyword arguments. So generally speaking, everything that we pass in here is an argument. But this asterisk ARGS is a set thing in Python, and it refers to a list of arguments. It could be 0 or more. That's why we have this asterisk, because it's kind of like a wild card. So like you don't have to pass any arguments. This makes it to where you don't have to list explicitly which argument you want to use. We could just say expect a make, expect a model, expect a year. We can write them explicitly like this. That's totally fine. But a much cleaner way to do it, and a way that you're going to see a lot, is asterisk ARGS. And that will again give us a string of arguments, or I'm sorry, a list of arguments. And the list, recall, who remembers, are lists ordered or unordered?
Order.
Ordered.
Ordered.
Lists are ordered, right? So they're 0 indexed and they are ordered. So the way we access the things out of the args list, and that's the name of the list, is args, is we just simply write the name of the list, ARGS, and then like we did before, we're accessing things out of the list, we put in the index of that thing that we want. So if we want the first thing out of the list, it's index 0. We want the second thing out of the list, it's index 1, so args 1. And if we want the third thing, say args 2, right? So the alternative to this, again, is we could explicitly write make up here and then write make down here. That works. But this is way more common way of doing it, right? Okay, so now that we've said this is going to be an ordered list, then all we got to do is pass in our instantiation these values in order, right? So we have make, then we got model, then we got year. So let's pass make. I'm just going to take our string for make and put it straight into our instantiation and remove line 15 entirely, right? So I just have just the string Chevy first inside our parentheses. Do the same thing with celebrity. Just going to cut it, paste it after a comma. So there's make first. Once again, delete line 15. And then just 1987 after a comma right there. So now I've collapsed all 3 of those things into just a straight comma separated set of things. All right, so this should work. Uh-oh. We got a warning. What's this telling me? A local variable make is assigned but never used. What does that mean? Anybody know what that means? Anybody see what I might have done?
You're gonna put the self?
Nice.
No?
Yes, you have to assign it to self. So remember when we did it outside of our init function and we just assigned these attributes directly in the definition of our class, we didn't have to do the self part. But now that we're doing it inside this initializing function or method rather, we got to set these to self, right? Because it's part of this thing. So referring back to it is how we do it. Good catch. So now when I save this, it should get rid of that problem. And now when we run it, it should give us the exact same output. Once again, it does. So it still says, I'm a Chevy celebrity. Nothing has changed. I'll just clear out my screen show again. So there we go. So we've refactored this to take in one or more arguments. Now, the downside of this is if you write it in this way, then the order that you put them in matters, right? So if we don't pass in the order that we have expected it to, and we pass them in some other order, the computer's not going to know. It doesn't care, and it's just going to give us the wrong information. So say I'm a 1987, and then it said model and make, because that's the order that we sent them to in. We did make, or we did model, then make, then year. And that's not the order that we want it to be. So we ended up setting these things to the wrong things because, again, we're taking an ordered list. So one way around that is another built-in thing using an unordered set of things, which, what's the unordered thing that's very common to use? Not the list of the ordered one. The unordered one, I said real common, is what? Do you remember?
The dictionary? Was it the dictionary?
Yes. Dictionaries. Very good. Dictionaries. All right. And remember, what is the main thing that defines what a dictionary is, or a hash map or a hash table? A dictionary in Python is what?
Yeah, key and value, but that can't be
Yes.
right.
Yes, that is right. Key value pairs. Very good. Key value pairs. That's the most important thing, right? So because they're stored with key value pairs, we can reference them by the keys. So the order doesn't matter. So the way we reference that, again, is something built in with 2 asterisks and then KW standing for keyword, and then ARGS, which is keyword arguments, right? So we can leave our, because it's an asterisk, this could be 0 or more. So if we don't use this at all, that's fine. So we just leave the args in there, leave space for somebody to put in arguments later if they like. And we just change this to keyword argument references. So we just got to prepend KW to this, so keyword arguments. And then again, we can't call the index because they don't have index anymore. They don't have indices. They have what? They got keys, right? And the key for make is just the string make. Key for model is going to be, again, the string model. And the key for year will be the string year. Oh, we can put KW in front of these. All right. So this is how we're going to access those keyword arguments, is by the key, which is the word that we're going to look for. Now, then we also have to make a quick change down here to how these are passed. So we have to label these inputs as those keywords. So we have to set the keywords as these things, right? So if we want the model, for example, to be our celebrity, we have to do model is the same way that we would set any variable name, but we're going to do it directly in here in the instantiation call. Same thing with make. Say make is Chevy, and year is 1987. You notice I didn't put any space in between these. That's just kind of save some space on the screen. It'll operate either way. It doesn't, the computer doesn't care about the spaces in between your setting operation and the name of your keyword argument. But now that we've done that and we've set this to the make, model, and year, that should solve our ordering problem when it comes to the displaying details method, right? So remember when we called it with keyword arguments and we put it in the wrong way, it put the celebrity before Chevy, before Chevy. Save this real quick and let's run this now. And that should have solved the problem. Should have made it back to 1987. There it is, Chevy celebrity. So that is, Shadiqua, to answer your question, really common way of setting up a much cleaner way of creating your classes and passing information to be used as the initial instantiation. So you use this init self, and then you use args and keyword args to set whatever values you want to do. Does that make sense?
Yes, and it didn't fully answer my question.
It didn't. Okay. What else do you have?
I wanted to know about multiple different mates, models, and years. Like, is there a way, or do you have to do it individually like this?
So you could make a function that would do it for you automatically, but unless you have one of those, you'll have to do it manually. Yes. Right. So whatever you could imagine as doing manually, you can write a function in Python that'll do that for you automatically. Right. So you just make another function that says like create cars, and it'll do it automatically. And you could have like a list of car makes and a list of car models or something like that. And you can make a whole set of logic that'll build that for you. But outside of that, no, you would, like in our example, if we want to do like a second car right now, then we would just have to do it manually and put these bits of information in there.
Okay. Thank you.
Sure.
And
Any other
would you,
question? Yeah, go ahead.
I guess but would you put it under this, or would you just do a whole setup all over again?
Yeah,
Like,
you could. So you could just do like your car and
okay.
then another instance of a car, and then just do model is, whatever you want it to be.
But keep all the other stuff the
But
same.
keep all the other stuff there, and then this will just work exactly the same way, right? And I don't know why you're driving a Toyota Prius.
Yeah,
but,
I would never drive a Prius. Just
I
kidding.
mean, that's my favorite. It's my favorite car.
I know,
right?
I
So
love
but
a
then
Prius.
so your car dot display details. Whoop. And if I spell everything right, it should work exactly the same way. And then we go back here, it should have two. So we got the 87 Chevy Celebrity and the 2012 Toyota Prius. And so then that's how this is used. You could just make any arbitrary number of cars using this exact same bit of code right here that just defines what a car is and tells it how to display the details.
Thank you.
Sure. Alex, you got a question?
Yeah, so you know how in the main you create my car equals car
Yep.
model celebrity, right?
Yep.
So do you have to create a new variable to use the function? I mean the class?
Oh yeah, that's a really good question. Yeah, so the reason that we have this is because the functions the instance has to be saved someplace. So you kind of do. You generally you do, or else it doesn't exist outside of the line that you call it in, right? Where technically Python will create it, but this, remember, a variable is creating a space in memory and naming that space. So to do anything with this instance of the car, you do have to save it someplace in your scope. So yeah, you do need to put in a variable set.
Okay. I did try like car without creating a new variable. I did try car model, and then after I put dot display details. It still works the same without any error.
Yeah. So if you, again, I was gonna say,
yeah.
if you just put all of this in one line and just run all this, is this how you did it?
Yeah. It still
Yep.
works without any.
Yep, it should work exactly the same way, right? So that's what I'm saying. Is so it won't exist outside of this line, right? So yeah, you could keep doing. If you do everything in one line, then cool. And if you're never going to do anything outside of that with it, then yeah, that totally works. So like there is nothing in the interpreter that requires you to save this into a variable. We just typically do because it's not common that you're going to do everything you need to do in one line. But
okay.
Yeah, good question though, man. I like that. That's interesting. I hadn't even thought about explaining that one. Ooh, any other questions? I wanted to show connecting this to our main file and making this a little bit more of what the applications are going to be like that we're going to see, and then leave you all with some practice writing your own algorithms as like the kind of homework between now and next time, or for whenever we can get to it. But I want to make sure that we're pretty clear on this before we move on. Any other questions before we go? All right. So what we're going to do, we're going to do another set of refactorings here to where instead of having this that we call directly, we've been calling classes.py here. And what we want to do is we want to have this go through our main.py. So we wanted this to be one thing. Remember, we had our container filler and we were filling boxes and stuff like that. But we want to now use our classes that we did in that. So to do that, we're going to take all this stuff that's inside of our app entry point, and I'm going to copy, get rid of it for now. And I'm going to take this out entirely. So that's gone. So all I'm going to have is our class definition, and I'm going to save this. And I'm going to leave this alone, and I'm going to close this classes.py, and I'm going to go into our main.py. I'll go over there and show you how we connect these things together. Right, so here's our classes.py, main.py is right next to it, the same directory. I'm going to open this up. And before I lose the stuff that I saved, I'm going to go back in here to our app entry point, and I'm just going to paste all those things in there, right? And so these are the things from before, from the classes.py file that we had. And when I save this, it should give me some errors. It's going to say, undefined name car. I don't know what that is. Because if you remember, our car isn't defined here. It's not defined in this file anywhere. It's in the classes.py file. So what we have to do is just connect these files together, right? So that this one app entry point will also be able to call things from that other file. The way we do that is a really cool thing. We can scroll up here to the top of the page. These are typically the top of the page. You could kind of put them anywhere, but by convention, we put these at the top. So make some space. They're called import statements. So and we're going to do these a lot. We use these all the time. There are things out there, modules and packages that Python has that are available that you could just import and make your life a lot easier. Like if you're working with CSVs, there's a CSV package that you could just do import and then write CSV. And then you could use this CSV thing and all the stuff that's in it. When you write and you're referencing your own files in your own file system, like we are here with classes, we have to put the word from first, and then the name of the file that we want. So classes, so from classes is classes.py. We don't have to put the extension, just the name of the file, no .py, just classes. And then import, and then the name of the class that we want to import, right? So from classes, import car. Everything lowercase except for the class title. And we don't need parentheses because we're not actually making a car class here. This is just importing the definition. So what's going to happen when we run this is it's going to read top to bottom, left to right in the sequential control structure. And when it gets to this part, the very first part is going to say from classes, import car. So we say, okay, cool. And it's going to go look in this directory, the same directory, since we didn't tell it to look anywhere else. And it's going to look for a classes.py file. And when it finds our classes.py file, it's going to look for a car class in there. And when it finds that, it's going to read it and it'll say, great, now I know that definition. And it'll keep going. And you see that I saved it. So now those errors disappeared. And so now it has this thing and we can use it just like we did anything else, just like we did with the stuff that's written directly in here, right? So now when we call main, this should give us, I'll take my container filler out of here because we don't need that anymore. Now it should give us our car information that we did. Actually, hold on, I got rid of this call and just have your car displaying our details. And I want my car also displaying details. Oh, all right. Cool. So when we save this, we're going to instantiate two cars, mine and yours, and print it out. But we're going to call it through Python 3 main.py, right? Not classes, directly through main. And there it is. So once again, we've refactored to where we could spit out these two car instances, but we're doing it through main. And we're using Python imports to do it. So we are right up at time. But I hope that last little bit didn't confuse anybody. That's really just doing the same thing we did when we did it all in one file, except now we're going just through our main file and we can have any number of other files we want. And that is common to put tons of other files and import them all through one thing and run it like this. All right. So in the last minute, what I want to do is show you the thing that is a great place to practice writing these things, using loops, manipulating lists, dictionaries, strings, integers, all that stuff. In our free coding resources that we sent out, if you go down to, it starts out with like self-paced learnings. There's a free code camp I plugged a couple of times. edX, if you haven't looked at it, amazing stuff. The Harvard CS50 course is great. But if you scroll down a little bit, the practice and interview prep section, there's two things in there, Code Wars and Leet Code. And both of these are used by people who are professional developers getting ready for interviews. And this is where you got to be if that's where you want to get. If you want to be professional, this is absolutely where it is. Code Wars is a little more accessible for beginners. And leak code is a little more focused on like really prepping for interviews, but they both largely do the same thing. And so real quick, just intro, we're not going to walk through an entire problem, but if you haven't been on Code Wars before, it's free. You can sign up for it for free. And when you go to it, it will give you a screen like this. And we have a list. I have a list I'm going to send out of about 20 beginner problems, but they're going to take you to a screen like this. Most of them are in Code Wars, a couple of them are leak code. When you get here, this section here, over here on the left, is going to have the directions of the problem you're trying to solve. So this one right here says write a function that when given a URL as a string, parses out just the domain name and returns it as a string. And then it gives you an example of a URL that you could get in and what you expect to get out, right? So this is the directions over here on the left, the instructions. And then over here where it says solution, this box here, is where you actually write your code. So here's a function, right? Def, our familiar domain name. It's going to take in a URL. That's the input. And there's pass that I told you. So this is just placeholder. So this is where you write your solution. Now, I'm not going to go through it because again, we're a little bit over time, but once you've written your solution, it'll run through these test cases. You can hit this test button down here. I'm not going to go through this, but this is some more stuff you can read. We've now seen import statements, so you know what's happening here, even if you don't know exactly all the details of it. The most important part is in this definition of fixed tests, and then we basic test cases. This assert equals is a really good thing to know in tests because it's giving us the known input, that's this google.com thing, and the expected output. And what it's going to do basically is going to check the input that you give it, this known input, with the expected output based on your algorithm and see what it does when you hit this test button. So I'm going to do this, and I suggest you start with this. You're going to fail, but it's going to give you, this is what you actually got out, and it should be that, right? And it'll tell you how many tests you passed, how many tests you failed, right? So this is how you practice writing algorithms. You go in here, you try to solve this problem. And once you've done it, once you've solved a problem, what's great about both Leak Code and Code Wars is you can see other people's solutions. So I've already solved this one. So we go to view solutions. Scroll down here, and then you can see other people's code. So my code is not nearly this slick. When I solved this, it took me like, I don't know, 15 lines or something, and I did it completely backwards of this one that's in one line and is super slick, right? But there are other people that did it totally differently. This is a viable way to do it. This works too. This is a viable way to do it. And you see all these different approaches. This one is really explicit. Tons of lines of code. Look at this. This guy's got tons. But these all work, right? So the point is, this is such a good training tool because if you go through the exercise of solving the problem yourself, and then you can see other people's solutions, it'll stack your solution up against theirs so you can compare it. It'll tell you how long this took in milliseconds when you run your tests, which we'll talk more next time about how to pick an efficient thing and how to judge how efficient your stuff is. But this is the processing time that it took in your CPU. So I'm going to send these out, this list of 20, and I really encourage everybody to try doing these and try as many of these as you can. Try to get these done. I've got solutions to them, so you get totally stuck and you really want a solution, I can send you my solution. It probably won't be the best, but it'll get you to that place where you can see others and get unstuck. But that's where I want to leave. I know we're a couple of minutes over. So I want to leave you with this, with our for loops, our while loops, our functions, and all that should give you all the tools you need to solve all of these problems. And that's just a matter of getting your hands on it and practicing it. You got any questions or anything before we go for the day?
So these links, when you click the link, does it show you, wait, what?
You click
What
this
does
link
the link do for you?
and it'll take you like to one of these problems.
Okay. And then
yeah, and then you can solve the problem. Like I picked out ones that should be good beginner level. Or we picked out a bunch of ones that should be like good beginning ones for you. There are
good based on what we've learned with you, or good based on what we may know just
no, just what I've just
organically?
what we've done here. It shouldn't be
Okay.
anything
'Cause
harder
I'm like,
than what you've already done. And
okay.
then once you're there, like once you're in this, there's a huge ton of these that you can, pick your own and filter down by newest and oldest and most complex and how hard they are and stuff like that. So we've gone through and picked out ones that are beginning level, that are mostly focused on strings and lists, and there's not a ton of math in here and stuff like that, right? It's fairly simple things that should just give you practice with the basic stuff that we've used already. But there's plenty more if those don't suit you, or if you get through those and you want to do more. These things got like thousands and just like hours of it. So Cool. That next question?
Yep.
Excellent. Any other questions? All right. Then with that, we can wrap for today, and I will follow up when the video is done processing. I'll make sure that this list of algorithmic challenges are in that, or the list is in that email as well. And then reach out with questions. I'll post it in Discord too. So nothing else. Y'all have a good night, and we'll see you Thursday.
Take care, everyone. Have a good night.
Thank you.
All right.
Yep. Thanks a lot, y'all.